This machine. Thank you. Let's do reshare, and we're doing this one. So can y'all see this screen?
Yep.
It's the wrong one. Oh, here we go. Here we go. Aha! I think we can begin. Right. So can you all see a screen that says Fluence and pulse width?
Yes.
Yeah.
Yep. Right, so I'm going to talk about fluence and pulse width, strange enough, because people seem to get quite confused, particularly with pulse width. So I thought, well, okay, the two go hand in hand, so we'll discuss both of them, and then hopefully it makes more sense. So fluence, what is fluence? Well, everyone talks about this in terms of joules per square centimeter. It's basically, it's the energy divided by the spot size area, and it's just really, it's the concentration of energy in space. In other words, in a physical dimension, flat surface, skin, whatever you want to call it, okay? So it's concentration of energy. And this concentration or fluence directly determines the rise in temperature in your targets. So the higher the fluence you fire at the skin, the higher the temperatures you're going to create in targets. That's easy. Pulse width, not quite so easy. Pulse width, we often see people talking about this in terms of milliseconds or ms or something similar. But the pulse width is basically how long the energy is switched on for, right? So if you boil an egg for 5 minutes, then the pulse width in that situation is 5 minutes. Simple as that, okay? And the pulse width you can look at in terms of the concentration of energy in time, right? So whereas fluence is concentration of energy in space, pulse width is concentration of energy in time. It's getting a bit Star Wars, isn't it? Space-time. I'm gonna get my And the thing about the pulse width is it also determines the temperature increase in your target. If you change your pulse width, you can change the temperatures quite easily. And I'll explain to you how we do that. So both of these effects, the fluence and the pulse width, can change the temperature. And ultimately, what you're trying to do when you're treating anything in the skin is you're trying to increase the temperature of something to some level to achieve the right result. All right? So how does this work then? Well, with fluence, it's quite straightforward. As you push the fluence up, the temperature goes up. If the fluence is low, the temperature is low. Simple as that. Here comes Tracy. Hey, Tracy. So it's a very straightforward correlation between fluence and temperature. Nice and simple. Pulse width's not quite so simple. It's a bit more, a little bit more complex. If you have a short pulse like this, with a certain amount of energy or fluence, you can generate quite high temperatures because the time you deliver the pulse in, this short time, might only be a few milliseconds, there's not enough time for the heat to escape from the target. It's all essentially confined into the target, okay? Whereas if you deliver a long pulse like this, then there's plenty of time for the heat to just leach away, diffuse, as we call it. And as a result of that, you don't get the same high temperatures that you would with a short pulse. Now, these two examples have exactly the same fluence. So if you had a fluence, let's say, for example, you're using a, let's say, a diode laser or an IPL, whatever, to treat hair, and you're firing in, say, 25 joules per square centimeter. If you fire that fluence in over a very short pulse, like, let's say, 5 milliseconds, then that will generate a higher temperature compared with the same fluence, same 25 joules per centimeter, over a longer pulse. So changing the pulse width does have an effect on the final temperatures in the targets, okay? And this obviously can have a negative impact. If the pulse is too long and the temperatures don't get high enough, then you may not achieve the result you're after. Because at the end of the day, it's the temperatures that are important, okay? So the pulse width does have a direct effect on the outcome. You can increase the temperature in the target by either increasing the fluence, quite simply, or decreasing the pulse width, or both. So if you're trying to achieve high temperatures, you have these choices: higher fluence, lower pulse width. Now, some machines, particularly diode lasers, don't let you do that, but I'll come on to that in a wee minute just to explain how that works. So when you have a pulse system, which includes your long pulse Alexandrite, long pulse YAG, and IPLs, then these are truly pulsed. So in other words, when you set the pulse width on the machine, then that's pretty much what you're going to get out of the end piece, the handpiece. But when you have a continuous system, which diode lasers are, then it doesn't quite work the same way. Diodes are kind of a bit different in this respect. Diodes are essentially continuous lasers. In other words, the longer you hold the button, the longer the pulse that's coming out of the machine. So what the manufacturers do is they chop the beam coming out. So the idea then is that you can set it on your screen, and you might say set for 25 or 50 or 100 milliseconds, whatever. And what's happening is the beam, the laser will generate a beam that's continuous, and then it will kind of like open and then close the gate. But the beam essentially is still continuous. You only get a little bit of it rather than the whole lot. Whereas with a pulse system, that doesn't happen. You set the pulse width, say 25 milliseconds, you hit the button, and the flash lamp just goes poof for 25 milliseconds, and that's it. It stops. So they're quite different sorts of systems, and this does create a problem. And I think a lot of people out there do have these problems with diode lasers. The problem with diode lasers is that they can have different powers, as we all know. So some of them might give you an output power of 1,000 watts. Some of them will give you maybe 2,500 watts, and some will give you 5,000 watts. And the problem then is, how do these all relate? Because it's not actually that obvious. The situation here is, if you have a 5,000 watt laser, then it's going to deliver 5,000 joules every second. Oh, there's my grandson. Hey, hiya.
Say hi quickly.
I just pray that way.
Sorry.
He's also a physicist, as I'm teaching him right now about all this stuff, and he's pretty good at this malarkey.
Oh.
A 2,500 watt laser will deliver 2,500 joules every second, and a 1,000 watt will deliver 1,000 joules every second. That's what watts mean. What is the measure of power? And it just means joules per second. That's exactly what it means. So how can we manipulate this in diode lasers? Well, let's say you want to generate a pulse width of 100 milliseconds or 10 milliseconds or 1 millisecond. 100 milliseconds is basically 1/10 of a second, 0.1 seconds, okay? So if you, let's say we have 3 lasers, these 3 machines here. If you decide to choose 3 options, 3 pulse width options, 100, 10, and 1 milliseconds, then how much energy, so how much wattage do you get, sorry, how much power? So from a 1,000 watt system, this one down here, in 100 milliseconds, which is 1/10 of a second, you're going to get 1/10 of 1,000. So that's 100 watts. In 10 milliseconds, which is only 1/100th or 1% of 1,000, you're only going to get 10 watts. Let's say 1% of this. And in 1 millisecond, extremely short pulse, you only get 1 watt. Okay? So that's what you get from a 1,000 watt system. What do you get from a 2,500 watt system? You get more, because this is delivering more joules per second. So in 100 milliseconds, now you're going to get 250 watts, because it's 0.1 times 2,500 watts. 10 milliseconds is going to be 25 watts. 1 millisecond, 2.5 watts. And then it's the same for the 5,000 watt system. Let's get this out of here. In a 5,000 watt system, 100 milliseconds will give you 500 watts, and then 1 millisecond will be 5 watts. So the problem here with diode lasers is you need to know what the power coming out of your machine is. Is it 1,000? Is it 2,500? Is it 5,000? Or whatever. Some machines do 3,500, some do 4, whatever. Because when you then plug in your pulse widths, if you can, that will determine what's actually coming out. Because all it's doing is just chopping the beam into small chunks, small segments, as it were. If you have, let's say you have this situation, you've got a 1,000 watt laser, and you have 100 milliseconds plugged into the pulse width. So you're going to get 100 joules in that time. That's the maximum amount of energy you're going to get, 100 joules. Whereas in a 5,000 watt system, you're going to get 5 times that, 500. And clearly there's a big difference between 500 and 100 joules. That's going to give you much, much more temperature, much higher temperatures. So a 5,000 watt system will generate higher temperatures for the same pulse widths. And this is where it gets confusing. And I know people are thoroughly confused out there by this stuff. It's unfortunately a lot of the manufacturers don't explain this, and it's kind of people are kind of left to their own devices, which is not particularly good. So what it means is the more power your machine can deliver means the more energy it can deliver in these same pulse widths. So they're not equivalent. You've got to be careful to try and understand that. It's quite tricky. So the thing about this then is if you're heating up the skin, you've got to cool it, because if you're throwing in, 500 watts or whatever into the skin, you're going to create a lot of temperature. If you cool the skin properly, you're going to have much more comfort because there's less pain involved, because you're not going to be triggering the pain receptors. There's lower chance of blistering because you're not going to damage the basal layer in the epidermis. Lower chance of pigmentation changes, because again, that's caused by overheating the melanocytes and melanosomes, and less swelling, less edema. So it's better all around. And what it means is, if you're using proper cooling, then you can use higher fluences, which means more success. So the success rate in all these treatments is directly dependent on the fluence. So the more fluence you can throw into the skin, the better the success rates. Absolutely. So I did just a quick diagram just to try and explain this. If you look at this is the epidermis, this is the dermis. These wee kind of orangey brown things here, this is your epidermal melanin, right, which determines your skin color. And then these wee lovely kind of star shape, I didn't know what shape to make them, so I made stars. These wee star shaped things, these are your thermal nerve endings. And these basically live just below the epidermis. They are in the dermis, but just below the epidermis. Look how close they are to the epidermal melanin, to the basal layer there. So in other words, if you heat up those little melanin sites in the epidermis, this heat will expand or conduct rather. Some of it goes to the surface, some of it goes deeper, and will trigger. Oh, yeah, it's running. Will trigger the nerve endings, and that's where the pain comes from. So you've got to have some sort of cooling system, and I always recommend. I wish this was. Oi, slow down, you bugger. You have to have some kind of cooling system. I recommend putting gel and then ice packs, because the gel is full of water and it will conduct 23 times more efficiently than the air. So there's no gel there. The heat just doesn't want to escape. It wants to stay in the skin because the skin's full of water. So you put gel on the skin surface and then ice packs, and the heat can escape quickly. If the temperature of these wee guys, these paints, oh, he's peace. If the temperature of these pain receptors goes above 45 degrees, you will trigger pain. If you keep the temperature below 45 degrees, you will not feel pain. Your skin, normal temperature in the skin, in the dermis, is about 35 or thereabouts. So it will cause, you only is a 10-degree rise in temperature to trigger pain. And that really isn't very, you can do that easily. So it's important to cool down the skin surface. So we give if we go back to this one here, hold on, back to here. The heat is trying to escape through the air, through the skin surface into the air. But the air is a lousy conductor, so it just can't escape. It's essentially trapped in the skin. This is why you've got to put on this water-based gel on the skin surface, and then the heat can flow into that much, much more readily compared to the air. So if you do that, you cool down the skin much more quickly, and hopefully, if you reduce the temperature of all this down here and down to a nice low temperature, you will not trigger the pain response. This is really getting on my nerves. This technology. So do cool the skin properly, because if you're going to start doing things like increasing the fluence or decreasing the pulse width, then you will raise the temperature of the epidermal melanin as well as your target hair or the blood vessels, whatever it is you're treating. So you've got to be careful that you compensate for that extra temperature by having more cooling. Always, always, always. All right. So that's pretty much it. So pulse width, you can change it to change the temperature. Fluence obviously changes temperature too. But when it comes to diode lasers, it definitely is more tricky because of the different powers. So the problem that means then is that if you have, say, for example, someone says If I say, yeah, use 25 joules or 30 joules per square centimeter and use it in a 20 millisecond pulse. Well, a lot of diode lasers will not let you do that. Oh, there's Kaylee coming in. A lot of diode lasers will not let you do that. You're stuck with whatever the machine gives you. So it's hard to put in those actual numbers. And then that means it's hard to know what's actually going to happen in the skin.
Am I in?
So, hello, Kaylee.
Hi, sorry. I had so much stress trying to get the app.
Well, fortunately, we're recording this, so you'll be able to catch it. Just finished, so cheerio.
Oh, you literally.
Literally. Literally.
No way, already so quick.
Yeah. I'm a quick kid.
We've not even started talking about diodes then.
So the problem with diode lasers is that they are difficult to understand because of all the pain, right? So I feel your pain, honestly. I see quite often people writing in comments on WhatsApp groups and online, whatever. And there's just so much confusion out there. And I'm not surprised. What you need is to have a physicist who can sit in the corner quietly and do all the calculations each and every time you treat them, right? Unfortunately, we're kind of thin on the ground. This is because not too many of us out there these days. But I am training my grandson, and he will be available for hire in a couple of weeks. All right.
Well,
I'm going to throw this open to questions because I'm sure you probably got some really hard questions for me. So who wants to kick off?
I do have a question about the MS. So obviously when we're writing in the group chat, why is it that Alex and ND YAG lasers have a much lower MS than diodes?
Repeat the question, please, while I try and figure out what you mean. Why?
So when I people write in about if anyone that's got an Alex or YAG machine seems to be doing, so they'll have their MS will literally be 1 or 2 up to 5, whereas my MS on a diode is like 220 at points. So
Right.
it's a lot.
That's because those machines are truly pulsed lasers, right?
Right. Okay.
The thing about a pulse laser is you've got a flash lamp, all right, and then you've got the crystal, either YAG or alexandrite, and what you do is you flash the lamp, and that stimulates the atoms in the crystal, and that generates the beam. Okay, so
Yep.
with the flash lamp, you can change 2 things. You can change the duration of the pulse, so you can make it either 1 or 5 or 10 or 100, whatever milliseconds, right? Whatever you like, and you can change the intensity. So what you do with those kind of lasers is typically you say, well, let's have the pulse nice and short, maybe 1 or 2 milliseconds. But to increase the fluence, you just increase the intensity in the flash lamp, so you get more laser power, right?
Right.
The diode laser, it doesn't work like that. With a diode laser, the way to increase the intensity is you make the pulse longer. Okay?
Makes sense. Yeah.
With a truly pulse system, you don't need to do that. You can just increase the intensity of the flash lamp. It's a bit like, you've seen these you can get lights in your house. It's got a little potentiometer, we call it. A little knob you can turn, and the brightness goes up and down in the room.
Mm-hmm.
Mood lighting, right? For when you're bringing around
Yeah.
the sexy man from whatever. I don't bring sexy men home anymore because I'm a married man now, so I can't do it.
carry on.
Plus, my wife would get very annoyed if I did.
Might cause some issues.
So you can change the setting so the lights go up or down, right? So what you're doing there is you're changing the intensity of the bulbs, right? So you get more or less depending how you change. And you can do that in a pulse system like a YAG or alexandrite or IPL. You can all do that, right? But with a diode system, you just, that's not the way they work. The diode systems are pretty much, as far as I know, pretty much they're on or they're off. That's it. You throw the switch and they come on at whatever intensity level, and that's it. And then they go off. So to get more energy or more power out of them, you have to extend the duration, the pulse width, the MS. That's how they work. It's quite
Yeah.
to the other system. And it's a pain, quite frankly. And then the other thing that makes life just so much more confusing is when you have a diode system, you can have a what we call a little array, and it's got lots of tiny little diodes in it. That array goes into your handpiece, and that's what you put on the skin, okay? But that array might, let's say, for example, that array generates 1,000 watts of power in total, okay? So that's fine, that's what it can generate. So to make a 2,000 watt system, you get two arrays and you put them together in the same handpiece. And now you get 2,000 watts. You want a 3,000 watt system, you get three of them and put them together. You get a bigger spot size because you now get three arrays, right? But each of those is sticking out 1,000 watts. So in total, you get 3,000 watts, but it's over a bigger area. But the fluence doesn't go up. The fluence is the same for each array. The maximum fluence might be, say, I don't know.
Hold on. Look at this, Mummy. I drew a big long caterpillar.
That's part of that question.
And it's Bumble.
Even my son for once.
Oh, you're asking about the milliseconds and the fluence. Okay, right. So the problem with diode lasers is you can add up all these arrays to make a bigger area and more power, but you don't get more fluence because each array can only give you a certain amount of fluence maximum. Okay, it can't go above that. So you add them all up, then you add up the power, but not the fluence. And all that means then is that you don't get more fluence, you get a bigger spot, so you can treat bigger areas like legs or backs quickly. That's all that means, right? But now you can also get some machines out there where individual array can generate more power. So the older ones might only generate, say, 1 watts of power, but the newer ones might generate 1,500 watts or 2,000 watts in the same array. But this is a new up-to-date technology. So that just confuses everything even more now, because now you've got to figure out, well, hold on a minute, you know, what is actually coming out of these things? What's the power and what's the maximum fluence, and therefore what's the pulse width, the MS? And it becomes really. So when I see people online and they talk about, I've got such and such a machine, or I've got this machine or that machine, and it's 3,500 watts or 2,000 watts or 5,000 watts, it becomes quite confusing because you need to know not only the watts, but you need to know how large the area is that's on the skin surface as well. And by knowing that, you can then work out what the MS and the pulse width and the fluence and all that is. But it is actually quite confusing, I have to say, annoyingly. With truly pulse systems, it's much easier. It's very, very kind of straightforward.
I was going to say, so really a diode is, even though it's sold as, like, a lot of people that are getting into laser are automatically buying diodes, but really they'd be better off buying an ND YAG for the simplicity of learning it.
Well, right, okay, so yeah, that's a good point. You could say that diodes are more complicated because of all these kind of extra considerations. So you got to consider the power and the size of the spot, all this kind of stuff. So yeah, they're more complicated. So in a sense, yeah, you're right. But diodes are also much cheaper, right? So the compromise you make is, well, okay, I'm going to go for a more complicated system to understand, but I save a lot of money. Or I spend a fortune and buy a simpler system to understand. The trick, I think, really is when you're buying or using a diode laser, the trick is to try and get to understand the way to get the best out of it, get the best results. And unfortunately, it's kind of it's apples and pears. When you see people online saying, I've got such and such a laser, this company, and I've got a laser from that company, you can't compare them directly. They're not equivalent in that sense.
Yeah.
Whereas if you've got somebody who's bought a YAG laser from one company and someone's got a YAG laser from another company, they're much more sort of comparable. You know, YAG laser is a YAG laser, but it's simple as that. And Alexandra is the same.
Yeah.
Diodes are much more confusing. They really are.
Okay,
Now,
yeah, that makes a lot. I've got another question, if you don't mind. When we were talking about the so the shorter pulse width, you get a higher temperature. So with myself, I treated I halved an area so I could treat on both. So I've done 95, 211, 1 on one side. And then I treated the other side on 174, 3. So very similar fluences, but obviously the pulse width is quite considerably different. But I had the same reaction on both sides. So it's just a different way of firing it, but get the same results.
Right. Okay. So you kind of you hit an interesting point there. You've got your fluence and your pulse width. Okay.
Mm-hmm.
Your fluence generates a certain amount of temperature, and the pulse width can generate or determine the temperature as well. So you've got this kind of balancing thing going on, right? The reality is there's a huge range of pulse widths and fluences that will work.
Okay.
Right? It's not like it has to be that fluence and it has to be that pulse. No, it doesn't work like that. There's a huge range, and as long as you're in the right kind of zone, then it should always work. Okay.
Okay.
The only kind of real difference there is that the fluence does have an effect on the depth. Trying to treat hair, for example, like bikini or underarm hair, which can be the deepest, then they do need higher fluences. Because if you don't get enough fluence deep enough, then it doesn't matter what you do with the pulse width. It's irrelevant. You've got to deep the dermis to get those follicles. All right. So there's kind of the way I sort of think of this nowadays is out of the two of those, between fluence and pulse width, the fluence is much more important, right? Because the fluence that really is doing all the work in terms of damaging the follicles. The pulse width is kind of like a sort of a fine tuning, you could say, but it's not nearly as critical as the fluence. So as long as you get enough fluence, then the pulse width isn't important. You've got a lot of leeway, right? And the has to be tied into the depth of the target. So deep targets need higher fluences, and shallow targets don't quite so much.
Yeah, that makes a lot of sense.
Cool. Any more questions?
Yes, I have one, Mike. When you talk about 5,000 watts or 1,000 watts, you are talking about end-piece watts, correct?
At the skin, yes.
Yes, okay.
Yes. Yeah, no, that's a good point too, because and this just adds to the confusion. You can look at these machines, and on the back they should have a boilerplate which gives you all the data.
Yes, and says 2,100 or 3,000, but it's the total energy of the machines with the power supplies and everything. That's it.
Precisely. So if
the important it's the fluence or the energy you have in the handpiece.
And that could be completely different. Right?
Yeah, of course. Yeah.
One of the annoying things, because you can have it's just the power rating. All electrical devices have a power rating. Basically means if you're supplying it with 220 volt, then you must have a certain amount of current, which means a certain fuse and certain power. So all machines have this. You could have your kettle, for example, might have a power rating of something like that, 2,000 watts. Whereas your TV nowadays is probably only about a couple hundred watts, so they're very low power these days. So lasers are the same. The laser needs to extract a certain amount of power from the wall socket. That might be, it could be 2,000 watts, it could be 3,000, 4,000, 5,000 watts, I don't know, whatever. But that's not the same power that is being applied to the skin. It's quite different. It's like what goes in doesn't necessarily come out, as it were. What goes in is the maximum amount of power that's available. Kind of the. I don't want to get into into the electronics of this. But if you've got a machine that says it's 2,000 watts coming out of the wall, that's powering the machine, then what comes out of the other end onto the skin can easily be less than 2,000. It can be actually more than that, depending on designs, more for pulse systems. So, but the two numbers are different. So when you see in the back of the machine that says power, it can say something like 2,000 W, or sometimes they say 2,000 VA, which is another way of expressing power. Then that.
I've just sent a picture of what the back of my machine says in terms of power.
In the chat, right? Oh yeah, okay, there we go.
In the chat.
I can't see that. Oh, there we go. So yeah, there we go. So your machine, it says AC input. Oh, yeah, that's precisely what I'm talking. Can you guys all see this?
Yeah.
So it says AC input 200 to 240 volts, 50 to 60 hertz, small z, and it says 1,800 to 2,600 watts. Now, gets calculator out, and volts. If that's say maximum 2,600 watts, oh, that's 12 amps. That's quite a lot. Right. So I suspect that, see that there where it says 1,800 to 2,006. That's probably just your power input, right? That's your electrical power that this device needs to operate. It doesn't. I'm pretty sure it doesn't refer to the power that's available to the skin. That's a different power. Okay, so, and you can't tell from that what the power to the skin is. Okay, and this you've got here. You've got a 3-wavelength diode and IPL and an ND. Is that a Q switch? Yeah, you got there.
Yes, I've got the V combo. So I've got the Q switch, IPL, and the diode.
So can you guys see this picture? I can see this picture here. No?
Yeah, I put it in the chat. I'm sure everyone can see it.
Screen sharing's paused. Here. I seem to have lost the screen. There we go. Right, okay, I'll leave it there because I'm having problems with technology. So yeah, you do have to be a little bit careful with what these numbers mean, because it isn't always obvious. In that picture there that Pam sent, I'm pretty sure the power there is the input power to the machine, not necessarily the power that's available to the skin. And in actual fact, if that's a Q-switched ND-YAG laser, then the power of that is enormous, because the pulse is only nanoseconds. You divide the energy by the nanoseconds, then it becomes huge power. So you're talking like millions of watts, hundreds of millions of watts. Righty, so right, any more questions on diodes and milliseconds and all this malarkey?
No, I'm all good. I've asked everything I need to.
Hopefully it's made some sense. But I've recorded this, so what I'll do is I'll post this up, and you can all go back and look at the recording, so you can see what all my gibberish was all about later, and think, what the hell was he talking about there? And hopefully, I mean, if you have any more questions, then just stick them on the WhatsApp, and I'll try and answer. The reality is that it is confusing. Okay, so don't feel like you're kind of feeling a bit lost. It is confusing with diodes in particular, and unfortunately, a lot of the manufacturers and suppliers don't help the situation, because they don't really explain it. I suspect quite a lot of them don't understand it themselves. But the ones that do understand it don't seem to be too keen to explain it properly.
Well, I think it's trying to help, isn't it? With them, like, I've always felt like you can't help but feel silly, because they try and make it like it's so easy, and that it's just you buy the machine, that's it, you follow your manufacturer's training, and you're good to go. When in reality, that is not not the case.
I think some of you probably saw a post recently about manufacturers' settings and my feelings and comments on those. I just think a lot of manufacturer settings far too low.
Mm.
I don't get good consistent results with them. So and that's why a lot of people struggle. And of course, the manufacturers will say, "Oh, but you should be following the settings and you'll be okay." But in a lot of cases, that's not true. They just are too low.
I think with the AW3 training manual, I spoke to somebody who's got quite a few of her of their machines, and she said just to more than double what was in the manual, and to always work on 3 hertz. So when I started doing that, I did find that I was getting, I don't know, I feel like I get better erythema when I'm on 5 hertz, but I've been doing the 3, and I suppose I am getting really good results as well, but probably not seeing as much erythema on the skin.
Well, do you know what? If you're getting good results, then that's ultimately what you're after. Getting a lot is kind of irrelevant then, as long as you're getting the good results. Now, the thing about the hertz, I mean, this is another thing with which people seem to be confused. Hertz is just your repetition rate, right? That's how you describe the number of shots each second. So if it's 3 hertz, you're going to get 3 pulses per second. At 5 hertz, you're going to get 5. That only really matters if you keep the handpiece either stationary or moving very slowly. Because then what you're going to do is you're going to pile up shots on top of each other fairly quickly, right? If you have, if you're moving the handpiece at a kind of a pace like that, something like this, and you're firing 5 hertz, 5 shots per second, then if you've got enough fluence and what have you, you should have like a shot here, and then one here, and one here, and one here, and one here, sort of thing. And that's okay. That's that. If you've got enough fluence, that's perfectly fine. If you're firing a relatively low fluence, then you probably do have to sort of pile up the shots by having a 3 or 4 or 5 hertz or something like that. Again, that kind of makes it a little tricky, because I've always said to people, if you use a high fluence, then you do not want to stack up or overlap shots, all right? If you have a relatively low fluence, then you can overlap or stack shots. So it just depends on what your overall fluence is, what you're sticking, and obviously the pulse to a certain extent as well. But it really comes down to fluence. Fluence is kind of like the overarching critical issue here. If you have a high fluence, then pretty much everything else is kind of trivial. But if you have a low fluence, and to me low is anything less than about 20 joules per square second, so that's low to me. If it's a low fluence, then the pulse width and the hertz become more important.
So if we were to, sorry to interrupt, if we were to use a really high fluence, do we still need to overlap? Do we still need to go back over? And I was trained.
Well, you don't want to.
You don't want to, because you've already put enough energy in there.
Yes. Kayla was about to say something there.
Me?
Yeah.
I'm so confused by everything, I'm not going to lie. I don't even remember. Is fluence and joules the same thing?
Yeah. Oh, you missed the start, didn't you?
Yeah, I did. I haven't been doing laser that long at all.
Sit in the corner.
And I don't even really like with the hertz. I only ever keep it on 1 and never change it, because I worry that if I put it up to 3, then I'm not going to get a very good result, because I don't go fast. I just go like really slow.
Okay. Which is fine if you have enough fluence. That's okay. If the fluence, right? But if
I was to put the hertz up, is that going to make a difference to how much fluence is coming out?
well, no.
Even if I'm still going slow.
Okay, so look at it this way. You can set the fluence, you can set the pulse width, your MS, and you can set the repetition rate, which is your hertz, okay? You can set all 3 of these things, okay?
Mm-hmm.
If you have a high fluence, then you want the repetition to be quite low, so you're not stacking pulses on top of pulses, because if it's a high fluence, then you might cause a lot of damage, excess damage that you don't want.
So keep it on 1.
If you have a high
No?
fluence.
Right, yeah.
this is the SHR technique. A low fluence being like, let's say, 10, 15, 20, something like that. If it's a low fluence, then that fluence may not be enough to generate enough temperature. So you do need to kind of stack up the pulses.
Mm-hmm.
You use a higher repetition rate, and then you would scan over an area. So the heat's building up gradually. But that's the SHR technique.
I just feel like I do it so slow, and I feel like I wonder if like keeping it on one is making it go slower. I feel like sometimes I'm there ages.
Well, yeah, one is as slow as you can go. Well, most machines you can't go slower than that, but it really comes down to what the fluence is. So if your fluence is
I
sufficient,
try and put it at a 21, which is the highest for the prime lays.
21 joules per square centimeter.
I think so, yeah.
Okay, right. To me, that's not high. and
That's as high as my machine can go.
yeah, okay.
They really feel it though. I even tried it on myself without the pre-ice, and it killed me at 14.
Really?
Yeah, without icing. Oh my god, yeah, it was horrific.
So, this is which machine? Sorry.
The prime lays?
You know what the power is?
No.
Okay, right. So this is where the confusion comes in, right? Because if it's a high power machine, then 21 joules per square centimeter, you can deliver that in either quite a short time, which means you'll feel quite high temperatures, or it'll be a large area. Is it a big area on the skin, or is it?
I literally keep it on the same for everything. Sometimes on the legs, I'll try and go up to 1.5 just to make it feel a bit quicker. But I worry that if I put the hertz up, then I'm not going to get as good results, even though I'm still moving at the same pace, if that makes sense. I don't ever do like the really quick one, which I think everyone says is dynamic. I don't ever do that because I didn't think I'd get the same results from what I've been reading and listening.
You can do that with that kind of fluence, and you'd be fine. You can do that with 5 hertz. And if you're scanning back, the point of SHR is that you're moving relatively quickly, right? Not
I never use that one. I always panic I won't get results. So I just go slow.
right. But the point of that is that you're putting in a lot of shots, right? Fairly quickly, building up slowly, and after about 4, 5, 6 passes,
But I only go for it once.
well, yes, but because you're sticking in at the maximum fluence. But if you fluence and increase your hertz, then you could do the SHR.
Do you think that's more I can't even think of the word, sorry. Oh my god. Does anyone know what I mean? Which one am I better to get results with? If I use the SHR or if I just go 1, 1, 1 with everything? I feel like I'm getting good results, but obviously I'm not sure if it is the best I can get.
If you're getting good results, stick to it. Don't change it.
Okay.
As they say. Right, ladies.
Right, okay.
Up now because they opened about 10 minutes, and in Scotland it's a holiday today, so I think, well, it is now. I've just so I can go to the pub and get a wee whiskey and some Guinness and maybe some breakfast as well. Oh, that'll be breakfast. Call that breakfast. Yes, excellent. All righty. So nice seeing you all again. Hello.
Cheers.
And I will post up this recording as soon as possible. All righty.
Thank you.
Oh, bye.
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 Thank you.
Bye.